Welcome to the video lecture series of module number 1 wireless, module number 2 wireless cellular and 4G LTE, module 2 lecture number 6. So today we are going to see how the multiple antenna transmission and reception takes place when it comes to LTE. Okay, so as we have seen in module number 1, various different topics of OFDM and how the OFDM will help us to transmit the information very effectively. Okay, so today let us see about how what is the role of antenna in transmission and reception if I use a single antenna, and what are the various parameters which can affect the performance of the LTE system. Okay, so there are various different parameters are there when you try to understand the concept of transmission and reception with respect to antenna. Okay, so if you try to have a single antenna, what will be the performance and the quality of service. Okay, and if you try to make use of multiple antenna, or simply you can say the array of antenna, what will be the topic, or what will be the performance over here. Okay, so let us try to understand how actually the multiple antenna transmission and reception takes place in LTE system, and what are the various advantages which we can have over the different or the conventional type of antennas. Okay, multiple antenna transmission and reception. Okay, so instead of using one antenna, we will use multiple antenna, or simply we can call it more than one antenna, both at the transmitter and the receiver. Okay, so if the case is like both, if you are using more than one antenna, both and the receiver, right, then we have to see, is there any advantage of using more than one antenna. Okay, and then what are the various parameters can be enabled, okay, if you use multiple antenna. Okay, so here the multiple antenna concept says that here, instead of using a single carrier, multi-carrier modulation enables. Okay, so if I use single modulation for only one carrier, then it becomes a bit difficult. Okay, so instead of using single modulation, or instead of using single carrier, we go for multiple carrier, or simply you can call it as sub carriers. Okay, you have seen in my previous lecture that the transmitter of OFDM, okay, it consists of n number of sub carriers, okay, which is applied to parallel to serial converter. Okay, so therefore that is the reason, instead of using one sub carrier, we go for multi-carrier and simply multi-carrier modulation. Okay, now if I use a multi-carrier modulation, what does this multi-carrier modulation provide? Okay, it gives us more efficient channel bandwidth. Okay, or simply we can call as multiple antenna and receiver in wideband channels. Okay, instead of using a narrow band, okay, in that particular narrow band, if I am transmitting some 10 channels, okay, but the required is some 100 channels. Okay, but my antenna will not be able to handle those 100 channels, or simply you can call those 100 receivers. So therefore, instead of using a small narrowband channel, we go for wideband channel. Okay, then the multiple antenna techniques can be grouped into 3 different categories. Okay, if you want to apply the concept of multiple antenna, then you need to go for some categorization of your multiple antenna techniques. Okay, so basically have 3 different types of techniques in multiple antenna: diversity, okay, interference suppression, then spatial multiplexing. Okay, so these are the 3 very basic multiple antenna techniques. Okay, then what do you mean by this spatial, okay, diversity and interference suppression? Okay, so let us see this one by one, how these 3 different techniques can help us to make my communication more simple and more efficient. Okay, so therefore spatial diversity is nothing but it allows the number of different versions of the signal to be transmitted or received. Okay, instead of transmitting only one signal, okay, what I will do is I will try to transmit the same number of copies, means multiple copies of my transmitting signal. Okay, or simply you can call it as original signal or baseband signal, simply transmit it to a multiple antenna. Okay, then which is received at the multiple receivers, then that will give you again correct information. Okay, so therefore spatial diversity is nothing but it allows you to use different versions of your signals, okay, which is to be transmitted or they can be received. Okay, moreover, and it also provides resilience against fading. The word resilience here means the use of nothing but filters. Okay, or simply you can call it as
avoiding the disturbances or avoiding the noise, okay, against the fading. Okay, then what do you mean by interference suppression? Is interference suppression uses spatial dimensions to reject the interferences from other users. Okay, other users in the sense either through a physical antenna, okay, gain pattern, or through other form of array processing such as linear pre-coding, okay, post-coding, or interference cancellation. This is the another important category of our multiple modulation. Okay, first is nothing but your spatial diversity, allowing the different number of different versions of the original signal both at transmitter and the receiver side. First category. The second category is nothing but try to suppress the interference, means try to suppress the noise, try to suppress the disturbance. Okay, and how to do that? Nothing but by making use of some kind of physical antenna gain pattern. You know what do you mean by radiation pattern, right? So we have here gain pattern. Okay, gain is nothing but your output divided by input, or received signal divided by the transmitted signal gives you the gain. Okay, so therefore try to analyze this gain pattern, or the other form is nothing but your array processing, okay, such as linear pre-coding. Okay, pre-coding means applying some kind of cyclic prefix, okay, then removing the cyclic prefix, applying some kind of post decoding, okay, that is nothing but CRC, cyclic redundancy bits, okay, some kind of syndrome vectors, or simply you can go for interference cancellation. Okay, and the another is nothing but spatial multiplexing. You know what do you mean by the word called as multiplexing? Adding two or more signals to a common channel, or simply you can call common bit stream. Okay, that can be sent it simultaneously in same bandwidth. Okay, if you do this such kind of multiplexing, the only advantage what you can get is nothing but increase in the data rate. Okay, means instead of using multiple channels, simply use one channel, try to go it for multiplexing, and then go for transmission. If you do this, okay, then you may find that this kind of modulation will help you to achieve a very good efficiency. Okay, and then of course the combination of techniques from these broad categories can be used simultaneously. It means that you can hybrid this concept. Hybrid in the sense, try to, instead of using diversity separate, interference separate, and spatial multiplexing separately, try to go for combining both. Okay, combining both in the sense, try to have in combination of diversity and interference. Okay, diversity and spatial multiplexing, or interference with spatial multiplexing, it can be anything. Okay, so therefore if you go for combining these kind of techniques, okay, simultaneously, you may still achieve a better signal at the receiver. Okay, now let us see how these three techniques help us in our LTE system. Okay, so in LTE, the current option includes techniques from all these categories. It means that the 4G technology which we are using makes use of all these three techniques, that is diversity, interference, and spatial multiplexing. Okay, and these three diversity, or these three categories, okay, they are oftenly collectively referred as MIMO systems. Okay, we have come across the MIMO systems even in antenna also. We hear this word many times, that is multiple input and multiple output. Okay, so this is nothing but a type of technique which we basically use in the communication system. Okay, and what MIMO consists of? MIMO consists of three approaches. Okay, so the first is diversity. It can be frequency diversity, or it can be time diversity. Okay, then we will see one by one what is diversity. Okay, then if we have interference. Okay, then the last is spatial multiplexing. Okay, but the problem here is the MIMO system is nothing but inaccurate unless there are at least two antennas both at the transmitter and the receiver side. It means that your MIMO system do not work or single antenna both at the transmitter or at the receiver. Condition ये है आपको minimum, that is I'm telling minimum, or you can still you can say at least two antenna, that is both at the transmitter and it should at the receiver. Okay, so let us see how this can be, how LTE make use of this MIMO systems. Okay, the concept of multiple antenna techniques. Okay, and how this can be help in efficient transmission of your signal. So the first concept here is nothing but spatial diversity. Okay, so the word spatial diversity is nothing but, it is basically used in wireless communication. Okay, simply you can call wireless communication. Okay, wireless cellular, it means with respect to the mobile communication. Okay, and then it can also be used in some kind of your global positioning system, or even simply you can call it a satellite communication. Okay, whenever when it comes to the communication, we basically use such kind of concepts. Okay, so what is the spatial diversity is nothing but, let us go with the overview here. Okay, the primary advantage of spatial diversity is nothing but relative to most form of time and frequency diversity. Okay, this is the third type of diversity compared other than your time and frequency. Time is one, frequency is one. Okay, but this is nothing but, this is the third type of diversity, third type. Okay, that is called as spatial diversity. Okay, simply just like your time domain, frequency domain, we have spatial domain. Okay, so what is the benefit of this spatial diversity is nothing but, compared to your time and frequency diversity, that is no additional bandwidth or power is needed in order to make the advantage of spatial diversity. Okay, that is what the advantage here. Okay, if you want to go for something designing of any circuitry, okay, compared to its fundamental, what we require, we go for additional power consumption. Okay, but here the spatial diversity says that, okay, that too in MIMO system, if I use an LTE technology, that I do not require any kind of additional bandwidth. The allocated bandwidth is sufficient for me to go for communication. Okay, and other thing is the power is not needed. More power means allotted power is the one thing. The second thing is, if I increase my circuitry, or if I increase my some kind of additional parameters to my wireless technology, or wireless in terms of wireless communication, obviously there will be a power consumption. Okay, so therefore I don't require any kind of extra power consumption for my designed circuitry or designed LTE system. Okay, so therefore that is what this spatial diversity plays an important role in LTE system, and it is nothing but, it's a kind of advantage for this technology. Okay, then instead of spatial diversity, okay, through more than one or two antenna which are separated by enough distance. Okay, that is the second parameter here. If you are placing an antenna, more than one antenna, you cannot place both the antennas near. Okay, I mean, there should be some kind of minimum distance. Okay, why we need to go for a minimum distance, or simply you can call it as enough distance. Okay, so just to why we go for enough distances, so that there should not be any kind of fading. Okay, or there should be minimum fading, or you can call it as decorrelation. Okay, if you want to correlate the signals, okay, between the transmitter and the receiver, then you need to go for some enough distance between the transmitter and the receiver, or simply between two antennas or two different antennas. Okay, then what is the problem with this LTE system again now? Okay, a small problem here which we may face here is the cost, because installation of one antenna itself is giving us more cost. Okay, now instead of using one antenna, and if you are going for more than one antenna, that is nothing but array of antenna. Okay, or simply you can call it as MIMO systems, then we may have some kind of problem with respect to cost. Okay, cost factor is another parameter here which we need to take. And the other thing is the space. What about the space? Okay, the space consumed by the additional antenna, okay, is again a problem, because already we have some allocated space for one antenna, and if I'm trying to increase my antenna more than 1, 2, 3, 4, that is nothing but arrays of antenna. If I place arrays of antenna, then first is the cost problem. Okay, if we manage the cost, then the second problem here what we may face is nothing but the space. What about the space? Space is already allocated. Okay, if I use more than additional antenna, then obviously there will be a space consumption. Okay, space consumption is what I should mount my antenna. Okay, then I should have transmitter or receiver. Okay, so ये additional हो जाएगा आपका. So that is the small problem here with the MIMO system, but somehow we can overcome this space consumption. Okay, then the second thing is the associated signal processing is required to modulate or demodulate multiple spatial streams may not be negligible. We cannot neglect this signal processing concept. Okay, because if I am using more than one antenna, obviously your signal processing means in terms of time, in terms of delay, okay, in terms of calculation of its complex additions, multiplications, in terms of FFT. Okay, simply you can call the n number. Okay, it automatically get increased. Okay, so therefore I should require a circuitry in such a way that it should handle the multiple spatial diversity. Okay, it should be both at the transmitter and the receiver. That is nothing but both when you go for doing the modulation and also demodulation. Okay, but somehow a small number of antenna, okay, which are providing the sufficient gain, okay, sufficient gain may have some good space, and expense is most modern wireless system. Okay, so this is the small brief discussion about the spatial diversity. Okay, then when you go for diversity, studying the concept of diversity, okay, we come across one concept called as gain, array gain, or simply you can call it as uh, gain array or array gain, or it can be anything. Okay, so what do you mean by gain? That is nothing but it's output divided by input. Very simple definition I'm telling here. Okay, that is nothing but output divided by input. Okay, it gives you the gain, it gives you the profit. Okay, now what profit we get if I use multiple antenna? That is the question mark here. Okay, so therefore when multiple antennas are used, okay, there are two forms of gains are available. Okay, so one is nothing but it's a diversity gain. Okay, diversity gain, and second gain is nothing but your array gain. Okay, so what do you mean by diversity gain? Diversity gain is nothing but which will be treated very shortly. Okay, results from creation of multiple independent channels between the transmitter and the receiver. Okay, and it's a product of statistical richness of those channels. Okay, because I have only one channel. Okay, I have only one channel but may have different subcarriers. Okay, or sometimes I may have some multiple independent channels, means there is some kind of a spacing between the channels. Okay, then if you go for finding the gain of these particular independent channels both at the transmitter and at the receiver, and if you try to go for some statistical calculation, that is nothing but dot product of those channels, then you may find the diversity gain. Okay, similarly we have array gain. Okay, so array gain is nothing but it does not rely on statistical diversity. Okay, between the different channels, we do not go for finding the statistical parameters on different channels. Okay, instead of that, what we do here, we try to achieve its performance enhancement by coherently combining the energy of each antenna to gain an advantage versus the noise signal. Okay, because noise is nothing but one parameter which is freely available in the channel. So one thing we get is nothing but that is noise. What is the second thing what we have to do here is just calculate the energy of those independent channels. Okay, and try to add them. After adding, you just divide it by the available noise. If you go for finding this kind of parameter, that is nothing but the energy of the signals. Okay, let it be independent or it can be dependent or it can be multiple channels or multiple transmitter or the receiver, with respect to this noise of each antenna. Okay, the condition is they should be uncorrelated. Uncorrelated means there should not be any same phase, any amplitude, okay, any frequency. आगे पीछे रहेंगे तो भी चलेगा. Okay, but so do not add coherently. Okay, so if you do this, then you will get array gain. Okay, so therefore if you find this diversity gain and array gain, okay, then you may come with and end up with SNR. Okay, that is nothing but signal to noise ratio. This is the one parameter which will be used always. Okay, because signal to noise ratio is one parameter in the communication where our complete efficiency, complete performance can be measured with respect to this SNR. Okay, so therefore if the received SNR is increased linearly with the number of received antenna, okay, then we may have some good efficiency at the receiver. Okay, so here they have shown some equations. Okay, will not go with all these equations because here they are nothing but it's y of I is nothing but your output signal. Okay, simply you can call it as the received signal is equal to hi of x plus ni, that they have written simply at hx plus ni. Okay, so what is h here is nothing but it's a h for all the antenna because they are perfectly correlated. That is what the condition is made, and hence the SNR on the single antenna is given by mod of h divided by sigma square. That is nothing but a standard deviation. Okay, if you try to find this, you may get some noise power. That is here the sigma square, they are represented by the noise power. It means noise power is equal to sigma square. Okay, let us assume that this unit signal energy what they have taken is a unity. All the channels are giving me energy is equal to 1. Okay, if you do that, we may end up with one formula here, that is nothing but my received signal y equal to summation, okay, ranging from the first antenna to the last, that is NR receive antenna multiplied by yi. Okay, and yi is already we have a formula here. Okay, so yi is nothing but here hi multiplied by x plus ni, or simply you can take this equation also. Okay, so in this way they try to go for finding the energy, they try to go for finding the SNR. Okay, SNR is represented by sigma. Okay, and the second thing what here they are telling is nothing but the combined SNR. Okay, if you want to try to go for combining the channels, okay, or simply combining the diversity and gain, you may have this formula, that is nothing but sigma rho sigma, or simply sigma rho summation you can call, that is nothing but mod of nr into h whole square divided by nr into sigma square. Okay, so hence the received SNR also increases linearly with the number of received antenna, and even if those antennas are correlated, we do not focus on whether they are correlated or not correlated, because at the last, if we have some kind of identical parameters, identical in the sense both at the transmitter and the receiver, if you are trying to have a kind of a match between the signal which are transmitted and which are received, okay, and if you are trying to apply the concept of our diversity and applying the concept of our array gain, then we may have properly linearity. Okay, that is signal SNR is increases linearly. We are not saying here it is just non-linear. Okay, so in this way we try to go for finding the array gain. Okay, so we may have again a diversity gain. I will not go with the diversity gain today. Okay, so just try to understand the concept here by reading line to line, तभी आपको समझ में आएगा.
Once this is a bit complex here to understand, because here when you go for multiple antenna, you need to study all the antenna parameters, okay, which you have already studied in the previous semester. Okay, so what is antenna height, okay, what is radiation pattern, okay, what is not, how to calculate the efficiency, what is beam array, okay, what is cosine, what is sine, okay, all those will come in here and it will add it to your formula. Okay, so in this way we go for finding the array gain, or simply you can in spatial diversity. Okay, so with this I will conclude my today's class. If you have any questions, you please ask.